Huh? Oh, Christian, hey. Dutch, is it streaming now? It's so strange. I pressed the button, but it wasn't streaming. So I have to start all over again. I'm so sorry. So I have this window for YouTube to let it stream. This window here, and I pressed the button start stream and changed the window, so it wasn't. It didn't react before I changed the window. That's why it wasn't streaming. I'm so sorry. Okay, let's start over again. Here it is. Cluster latest state. This MCU is setting an address and on the address bus, and these MCUs are blinking if they identified their address, and the address is stored in the option bytes, and it's really difficult to do this. I needed like to. Why is it focusing, defocusing? I think the LEDs are confusing it a little bit. All right. So what I needed to do is I will show you here. Hey Peter. Oh yeah, and also hey Dutch, you missed the hello before. Yeah, what I needed to do is, this is the main. So whenever I did a funny thing, I can maybe explain, because I have the issue right now that I can set IO0 with this programmer board that we have here. This one here, the programmer board here. We can only set IO0 here, and IO0 is at the same time connected to the LED. And yeah, we are using it to basically acknowledge stuff and so on. So I made it so the main MCU is using the pull-up. Hey! Hey Basil. So I used, maybe I can show that, set MCU pin. Nope. Yeah, I think I made it. How is it? Or on the MCU, yeah, it's never pulling down, so they won't interfere. Here, blink. You can see that. Wait, LED is either push pull if it's high, and it's floating if it's not high. So it's never going down, and the main MCU can use the pull up to basically notify the MCU that something's happening. And I'm using that in the beginning of this whole thing to program it. Wait, when do I do it? Yes, here. No, wait, input mode. Here. So I can just write, I set the bus data, and then I use the I as index of the MCU. This is just a token, so the MCU knows bus data is set. Then we set the MCU pin, which is just pulling high the LED. So the LED is actually dim, but it's above the threshold of the high value. So this code here, this is the LED stuff / option data. Super weird. I had to copy it from Charles' library, because we need like to copy the other option bytes and then erase it and stuff like that. It was so confusing. Yeah, write ID. It basically checks if the pin is high, the LED pin. Then also checks if the instruction is set index, and then it will acknowledge with a flash and with a high. Write the address to the first byte. Yeah, it is strange. Even if I do that, and then read back the flash, it doesn't show actually. It's like super strange. It took me 2 days to make it work. And yeah, then it waits until the pin is reset again. So basically what happens now is in the main, it checks if the LED pin is pulled high, and if on the data bus we have the ID, write ID, the set index, and then it will write this in the option binds. So that's the method that I used that worked here, and there were like awkward stages in between, because this doesn't boot sometimes. I don't know why. Probably boot 0 is wrong, or I don't know. I can't program them without disconnecting them from the power, from the USB power, and so on. So sometimes I had like a floating stage on the pins here, and they would just flash a random ID and override, and it was a total chaos. Now it works, and I'm happy with the result for now. I would really love to have like both pins connected to both of the I/O pins connected to the MCU. I would need like to remake this one to have that, because otherwise I could use like one pin to identify, or both pins, like in a matrix. Like if both pins are high, then we address exactly that MCU. So otherwise, if I want to use for the bus communication pin interrupt, then all MCUs that are connected to the I/O will go into interrupt, even though they're not manned. Hey Johnny. Long story short, I'm ready to put something on the MCUs, and I wanted a distributed raymarcher. It's not a ray tracer actually. So and I asked ChatGPT, people, I take everything back. As when I said it is flawless, it's not flawless if you have hard tasks. So I tried. Let me check if I can find the chat log. I just reopen. Too many windows. Threshold of too many browser windows is real now. And and I open every browser window twice and 3 times or whatever. Okay, so let me check here. Ray marching, fixed point ray. I tried that. Okay, so what I try to get ray tracer that works with fixed point integer in multi-threading. Make page where set how many threads and an example canvas with simple scene is ray trace. Ray marching is also fine. The worker thread should fetch from the main thread the direction of the ray and return a color. So this was my request. It actually implemented something. The issue is, it was changing over and over because I had to make more and more changes to it because it didn't work. It just locked up. And at some point I had to give up. What I used is I used shader toy and got an example there and translated it to JavaScript, which is basically here. Yeah, so vibe coding wasn't that great. Major task not doable. So I just took some shader toy ray marcher and asked it to translate it, and it had some errors there as well, but at the end I decided I will do it a bigger vibe. Yes, I decided to do it myself. I took the state of ChatGPT, and the result is here. So I rewritten it few times already, redesigned it. It's still stretched. I don't know why. The aspect ratio, the aspect ratio, it looks wrong. It looks stretched, but I don't know why. It's strange. This is working with ray marching here. What I did here so far is basically everything was implemented in maybe, but there still will be. I mean, you can still do recreational coding, and you can't wait. Yeah, the issue is that basically we will be screwed over. It's not the work will be done, but the resources will be distributed even worse than before, so you don't get anything in the end. By AI VTuber, yeah. Peter, what did you do in your old job? I think the stream title. Oh wait, what? I said I scheduled it as a stream. Okay, let me. Twitch isn't smart because I scheduled the proper stream title, but it didn't take the. It didn't use it. Okay, here we go. You find a video? Okay. Curious. Yeah, so it had only an example of few objects, and I just put everything in classes, also the objects, because currently what we have is okay, this is vector 3. We have SDF, that's the signed distance function, basically this is where the distance from the objects are calculated. So short update on how ray marching works is, oh, Amazon sorting. Oh, so that was like permanently wearing out and you had like to do the same thing over and over again. Okay, ray marching, you start with array and step, and you have like defined a sphere with the radius. So this is the radius of a sphere, and you calculate basically, you step from the eye. Let's say this is the eye. Okay, you calculate just the sign distance function calculates the distance to the next object. You have maybe like a box over here or something, and the distance function is usually very simple to calculate. Yeah, and you can basically, you have like, okay, I need to do it like that. And then it's an iterative function, and then you go just in the direction of the last shortest distance that you calculated. So basically it will get smaller and smaller steps here, even though it might like new NVIDIA tech? No. And this is old school. It's been around forever. Yeah, closer and closer. Sometimes it might not even hit and pass by, and you hit like just an iteration limit or something. Hey, web bustler. Anyways, this is how ray marching works, and you can. It's not ray tracing actually, because ray tracing is a little bit more sophisticated. You can like. The normals are calculated by approximating, like if you have, let's say we hit, this is our collision, we calculated just the distance from like the gradient of the distance, and use these components to calculate basically the normal of the object, and something like that. You can do like way more sophisticated functions, distance functions, and fancy stuff with that. Anyways, yeah, this is how it works, and I would like you need to watch some shader toy. This will kill my let me get something. Browse here. Here is Python tube. Here is also for you can see the simple math lets your brain shut down. Yeah, it's actually quite simple linear algebra. It's like, I mean, here you can see even the normal is calculated. We just call the SDF and it calculates the shortest distance. It's almost the same. It's basically, I mean, you could do the benefit of raymarching is that most of the time the calculations that you have to do to approximate the distance or calculate the distance are very basic functions that work like with the opcodes that we might have already. So this is just, we have like let's say to calculate the distance from that cylinder from any point in the room, we only need addition, this is multiplication, subtraction, so, or a sign change and a subtraction, and max and minimum. That's, yes, that's basically, the square root is the worst. And there is one issue though. If you want to do the shading also, you need to calculate it, or the reflection you might need to. So this is the length, this is how you calculate the distance of the sphere. It's just the position minus the position of the sphere minus radius. That's the distance of the sphere. Or the sphere's surface actually, because we get like negative distance towards the center of the sphere. Alright, and there like a plane is also quite simple. It's just it's just subtraction. Quite simple stuff. And this is what we can do most probably on the MCU, on these cheap MCUs, because we don't have a floating point unit. We can calculate square roots, we can calculate divisions, we can do anything there. The only issue is like, where do we start? I mean, when we can do the main render and basically say, alright, each of the MCUs will calculate 1 pixel and return that. But calculating a pixel is quite difficult, because then you have also to use like floating point for specula, or wait, where's the normal? Yeah, here, normalized, there is the square root. We can calculate, I mean, this is like calculating the normal in this case is most expensive. What we can do, let me get back to this example. Let's erase it. What we can do is, we have like our viewport here, and we send out, we have like a sphere, a box or whatever, and we send out a ray. Let's say, okay, this is bad. Let's send out the ray over here. Boop. And this would usually reflect like that. Then we have also a light source, like here. And we need to calculate a secondary array here to check if there is like an obstacle and we are in the shadow. So the reflections and so on. So calculating this, we have like many iterations until the collision. Boop! Until this point. And then we have iterations over here. And we have iterations over here. And potentially, if we have even more reflections, we have even more iterations over there. and also we need to calculate if the box is in shadow. So there are many arrays that we need to step through. Oh no, what? Yeah. Dyslexia. I also hate reading. I can read maybe data sheets. Here we go. Yeah, so what we can do now is my goal is to rewrite this thing. So the task of marching this is one MCU task. Then the MCU basically calculates the stepping from the starting position until the collision, returns the value, and then the main CPU is doing the reflections and whatnot, mixing, color calculation. A full map. The portal? What? It's always like, look at this. We have reflections here. So actually you can see the sphere here and the shadow of the sphere. You can see reflected here. So we can even look on the other side of the cylinder in this reflection here. So, and there is also here's shadow and so on. So we can look like beyond what we can initially see here. This is why like this ray is going like in this direction forever. This is like we could have a mirror or something and put something behind the camera, and the camera would be invisible. So to simplify things, we can just take like each stepping job, send it to the MCU. When the MCU is ready, continue from there. Too much for your brain? Oh, Adam. It's not... Okay. I guess. I mean, I can... This is like the viewport. Let's say this is the viewport. And we will just put... We have like many tasks, and we can let many arrays at the same time for each of the pixels. Let them schedule and wait for the result. What I am wondering though is how we solved recursion here. So we can schedule like all the rays, then we would need like to return from here and basically keep everything there in mind. Maybe I can show it in the code. Code is easier. Yeah, here is a reflection. It has a recursion depth, and there is also a limit. It would just call itself and then mix the color with what we got here. Instead of having that recursively, we need to keep track of the color and just pass it, because after that we just do the mixing, which is alright. Oh, we have like we calculate also the shadow ray. So we have two rays here. This might be an issue. How do we do that? Shadow ray. Okay. This is actually tough because we need to split this up into small tasks that we can just put into a worker. So the stepping, the distance function, and here are the distance functions. We can make an interface to calculate it in a fixed point integer and do it in shadow. Okay, so this is the shadow ray. Maybe let's start defining tasks and a task list. Okay. So class and task. Construct what we usually do, we have maybe a parent, since it might be a recursive task. Then we have maybe X and Y for the pixel that's responsible there. We have the color is the return value or not. I don't know. Render task. Okay, let's start with a parent. Then we have class render task shadow. And then we have render task color. We could also use the same task to calculate the shadow if we trace it back. So from the source, if we use the same. Oh wait, we need to. There, not all of the objects are concave. So if this is like a torus, it might cast a shadow on itself. So we actually need to walk the same distance here. Render task shadow, okay, constructor. Parent. Then we have light position, and light distance. Okay. So constructor, and this one here, wait, render task, color, constructor, parent. You can all fade out and listen in the background while doing more interesting stuff. Render task color, we actually okay, if there is no parent, there will be or let's say we do a render task pixel or viewport. Okay, render task viewport, constructor parent. Why is this locked here? Why does that show here? Oh, that's why because it's render. Ah, yeah, okay, the stack. Okay, constructor parent viewport, and we have x, y. The only thing that I'm wondering is this render task viewport will be the one that's sending the actual pixel calculations. They all can do this. Okay, render task can do this. Or scheduler. Hey Johnny. Hey Jordy, I missed you. You said hello. Bonk. Scheduler, okay, constructor. Tour. This might what's a static wait at is there a static variable or something and JS classes. Let me check. Oh, where are you currently? Static description. Okay, yeah. Static tasks. Okay, so add task. All right. Okay, render task. This parent. I might remove also YAML. Look, it's tabs. Hey, private Jan. I'm trying to make this raymarcher, rewriting it to work with all the marching rays will be outsourced to a supercluster which consists of 160 of those little MCUs. So we need to convert this to this JavaScript code to work with work with fixed point arithmetics, because these MCUs don't have floating point. And currently I already rewritten it a little bit, and basically this Luniasm diagram looks like slants growing from a toilet. Wait, what? Low power DIY Intel Laravel, yes, more or less. Yeah, so these are like 16 MCUs on there, and I have 10 of those that will go on this M.2. So actually this is how it looks like in the end. 10 different ones. I hope it works. I mean, we got most of the parts working. And yeah, now this will be, I want to write basically the code to put it on the MCUs already, just to have the first example. Any MATLAB channel? No, sorry. Spankty. I don't know any MATLAB. Do you want to learn MATLAB or just interested in stuff like that? Alright, so yeah, I want to split up. This is the shadow rays, light position, light distance, and we get the return value. Let's say we calculate it here. So basically render tasks, perform or execute. GPU like pipeline? Yes, more or less actually. Oh, you have a project on it? Yeah, I can't help you with MATLAB. You need to use ChatGPT. Or do you want to brag? Ah, right, okay. Yeah, use ChatGPT. It's probably proficient in MATLAB. It's basically graphic pipeline. Alright. Simulink. No. Alright, is in shadow. So what we will do, distance to light shadow, we will use this part basically. We start with the position and light position. Okay, this is the position, light position, and there's too much stuff. I might want to split it, not all in one file. Render task shadow. Execute. This basically will be happening on the other side, on the MCUs. If they return, execute. So this is real execute. This is just my simulation. Render task color. So render task color will be basically doing this stuff here. So this waiting for shadow as false, this waiting for a reflection false. Color. Render task shadow. I need to put it somewhere here, like a new renderer. Okay, let's start over again with this part. Coding. Yeah, I forgot everything. So what we are doing here, we will just add scheduler, add task, and then new render task viewport, and then we will do parent is not, oh yeah, that doesn't have a parent here. Render task viewport doesn't have a parent, so this will be null. Viewport x, y, what else do we have? That's actually it. So this part, so this is the old renderer. This part will be happening here, viewport. For now I'm confused what's happening where. There's no rotated position. That's all old stuff. Okay, so this X and Y. Oh yeah, we have data. No, we should do it already here. Yeah. This is where we schedule the task. And Y, and this is basically direction. This is RD, ray direction. And then what happens is this is data, put image data, now and then it should be basically while waiting put the data. So this will be waiting. Or we do after each pixel that's done, it will put the image data, which is really terrible. Okay, we can just add the scheduler. Scheduler execute and then put image data, and this part happens in render task viewport. Okay, we got this. Oh wait, ray origin is also missing. Ray origin, so ray. For position and direction. So this I got the reflection. Oh, this. Return color. Return color, and this will be basically that. So it starts with that. Then when it's executed, it will, and then return color. This happens in a new task though. So execute is basically scheduler add task. New render task color. And this will be basically, this is the parent. Then we have this the position. This is direction, and we have the max iteration. So Okay, this max depth starts here. This was 2. Add task, render this, blah blah blah. That's it? Okay. Render task color is next, which is basically oh, this is wrong. This is shadow. Shadow, light pose distance. Okay, here. Position, direction, and depth. Okay, we are doing the same stuff here. Waiting for let's call it like it's actually is. And then let's do get reflection needs to go there. So origin, direction, depth. Okay, this goes there. But this is hardware. So this happens in hardware. That one steps. This is basically I think I will remove the shadow rays at some point, but okay, this whole thing, this runs SDF, DSK here, this part here, this is return if shaded. Return shaded. So this part is return collision. Okay, here. We're just calculating the collision on the MCUs, and they will do that here. So get null. Call. That will be the collision. Shaded this color. Okay, in shadow. This is reflection and this is shadow. So we need to split it even more. Return collision. So this eating for collision. Okay. False. So this is actually broken down to the hardware task. This is what's happening first. It's like promises and stuff. Asynchronous execution. So this is waiting for collision, and they might be returning at different stages. So if we execute here, this task, let's put it in a new task. Oh, I forgot render task collision or SDF. Let's call it collision extends. That's what was missing. Render task. Okay. Constructor. What's going on? My stream broken. Someone pings me all the time. Where is this coming from? I will mute every server that pings me. Where's this coming from? No, Discord is annoying. Constructor. Okay. This is the part that executes in collision, and this is basically what we will outsource. Collision. Parent return collision. Okay, we have a collision that has null. Can we return collision null even? Collision or object null. Is there always a collision? SDF, yeah, it can return null if there is no object. hit. Okay, this is the current state. This happens, return collision. This happens here. If which is really strange, that should never happen. If it's shorter than return call, okay. Otherwise it will iterate more and more, okay. What is T? Oh, there's something missing. Where is T coming from? Here. That's the actual travel distance. Here, T. Origin, that's basically parent, pause, steer, super, parent, this. Okay. I can optimize this. This is like, don't like that it's not optimal, but actually that's the travel distance. That's really cool. We should add this to the return value. Here, return collision T. Let's do 0. There is nothing there. T, and this is const max distance. So let's put it here, and 64 steps maximum. Okay. This will run on the actual MCU at the end when we are done. Okay, here. Oh yeah, by the way, I need to return here. Here. Because otherwise it will run indefinitely or execute too many times. Okay. Now this calculates the normal. This will be, there is no collision, T, return, and then parent, return, color. Okay, we'll use this one here. I have a function for that, but alright. Okay, this is that. Happens if then we calculate the normal, we calculate the shade, what I'm, hey 404, so I'm trying to write basically a pipeline for a distributed raymarcher that calculates basically this here on the MCUs. So currently it's working in a recursive way, like you send this ray out, it collides with the sphere, and then the sphere might reflect a ray towards like the cube, and also it calculates if there is a shadow to the light source, and then the reflected ray also calculates the color of the cube, and calculates also the shadow and even more reflections and so on. And I want to put like these steps in between, yeah, on the RISC-Vs, and they have no floating point unit, so I will do only like the stepping of the raymarching in between, like those sections will be put on the MCU because that's like an iterative process, and the actual color multiplications, normal calculations and so on will happen on the PC. So a little bit of cheating that could be also put like on the main MCU, but that one doesn't have floating point unit either. So yeah, we will just adjust. Yeah, It's easy. There are no square roots or divisions or anything. Distance functions are easy. Lurking mode. Yeah, it is still. Are you still? Yeah, no, you're now. Hey, Graustreif, I missed that you joined. Lurker mode. All right, so now I put every like step in between, like calculating the direction here. This is a task. Then it sets off the raymarching task, and then when this arrives, it has to calculate this task and this task. So it will need to schedule more and more tasks, and I have no clue how that will work. Schedule. Maybe I'm wondering what happens if we have like all this tasks scheduled and then yes. No, not HTML on the HTML will use serial to send off the tasks to the MCUs. So that might be actually the bottleneck. And then return will be just the values that we get from the collisions. So I need to split it up for now, and something like the collision render task collision, this part, and the collision detection or the distance functions, and they will be implemented on the MCU. This is just a simulation, or let's an intermediate step to split it up to make it like asynchronous with every single step. All right. I'm a little bit nervous with my mouse wheel. I'm sorry about that if you try to read the code. Alright, now I have my stack in my head. Okay, a collision is calculated. Now we need to calculate the normal with the collision. That's alright. The shade, the light position is here, which is hard-coded. This needs to be fixed. We would need like to... I mean, this happens anyways on the main PC so far, so there's no need to fix that now. I don't want like to upload the MCUs too often. Okay, is in shadow. This is like a shadow task. So who is nervous with crappy HTML? Nothing against your auto, just against it's mostly JavaScript. The benefit is you don't need any proprietary software to run it everywhere. Except for Chrome and maybe Edge or Safari. And sometimes Firefox. Opera might work. Sorry, I'm yawning here. Yeah, light is in shadow. So what will happen here? Return collision. Now we will scheduler. add task, new render task shadow. Render task shadow is actually the same as render task. Okay, because that part is similar to Eesh. Okay. Light direction. We would switch that P sub light position normalize, and this is what happens afterwards. We calculate distance to light. Pflaster Chuck. Christian, you're also in lurker mode. Is this right? Light position, light direction, and then we will just send distance to light or the hit position. Shadow, and then it's also using fewer steps. Interesting. Return type. Direction scale D. Okay, it also cancels the shadow ray if it's missing. There's an optimization that we can distance to light. Okay, distance to light, we will do that. Break. Return false. Okay, so what we can do is collision max distance is basically max distance is and max steps and max steps. So this was what we were using there. This max distance is basically this max steps It's a lot of communication though. The packet size is quite big. Might want to keep that render task collision. Okay, I need to find the color task and take those two. Return collision. Huh? But where's the first part of that? Oh, is it viewport? No. Render task color. I lost something here. Or I maybe never scheduled it. Yeah. Oh, what's my this here? That's what I'm missing. Scheduler add task new render task collision. This. This position, this direction, this max distance, max steps. Okay, this was executed. Hey, Quindor, how you doing? So this will be that. Shenzhen! Did you make LEDs or what? What did you do there? Shadow steps. Oh. Max distance, distance to light. Oh, right. You want to be certified with your products. So was it under the radar so far? Or how did that work before? collation. Distance to light. Oh wait, what happens? Yeah, if it travels further, it shouldn't travel further though. I'm not sure if this is smart with the shadows. Okay. Waiting for collision. Return collision. So this false. Return shadow. Shadow. Oh. It's interesting. It will call the same function. True. Hey, Ameboid. Yeah, we're trying to make this raymarcher distributed on the supercluster. There's one here, or even more 160 cores, but making it like distributed is difficult. I might want to move everything into execute, but we will find out soon. Scheduler a task. Okay, this waiting for shadow equals true. Else if this is waiting for shadow so we also need to store this now we will need that Distance to light. This call. Let's put it here. Oh wait, the color doesn't need to be here yet. Distance to light, light position. The color comes later. Collision is stored. Distance to light. Alright, here we go. Waiting for shadow. Then waiting for shadow is done. I think this will all be here. Probably someone comes around the corner and tells me, oh, why don't you solve it with promises? Not really proficient in that. And also I will put some of those tasks on hardware. Color. Okay. Distance to light. Also T. T is the maximum path. Okay, if T math IBST, or let's say distance to light minus T shorter than whatever 0.2, huh? Then, or let's say let this hey Tops Pops. Okay. I'm wondering if the tasks should be completed every time, not like this one being split in 3 subtasks or whatever. Okay, in shadow, then we get some light. And this is the reflection, alright. And we need distance to light, this. Oh, I have an idea how to do it. Maybe. Waiting for shadow. Lights to distance to light. Here. Oh, this. Okay. So I would calculate shaded. So basically this shaded if in shadow, else. Let's get performant here. Shaded this. Okay, shaded true by default and distance to light. Oops. Okay, this shaded. This is what happens when we are done, basically shaded. And then we wait for the reflection here. Yeah, it will be really slow over Syria. But I don't care as long as it works. I hope I don't know if I can change the baud rate. Yeah. Yeah. It's just a demo. Lurk board. You can click a button and it pastes something in the chat. Nice. Okay, now this part is going here. This depth. Nice. This depth. Here. Depth. So if depth, then call object material reflection as if it's higher, it's more reflective than 0, then it will calculate a secondary reflection, and then we have shaded this mix reflection, let reflection. Hey Jumbo. And here we schedule yet another render color, render task color. This is the same here. So how is it going? Hey Artem. Where is P coming from? Oh, this position. No, wait. This is the collision, so it's basically called collision P at collision N. It starts basically with a little bit of offset, reflects this, and also this collision, because that's a different collision, my friends. This collision, this. We are here in a shadow task. It's a little bit convoluted, I'm so sorry. Direction. And this direction, collision NP, light position. Yeah, I can do this here as well. Light position is a little bit annoying because wait, I can put it here. This is so really annoying. Okay, light position, color is shaded here. This collision material, otherwise it will be depth. This direction reflect. Yeah, you're not seeing all the code anymore. This depth, and then we have this is only happening here. ESP, so few months maybe. Just enjoying those right now. Okay. Else. I have used them now and then, I believe. I don't know. Maybe. Oh, you're right. Might be last year. Parent return. Yes, a little bit. You need a link key most of the times, or like a serial connection, similar to ESP32. ESP32 S2 and S3 are easier. Parent. Yeah. It has Jade. Don't ask me the details. I'm using the link key because I got them, but you can use basically serial and there are open source linky fake linkies, ESP32S2 programmers as well. Some laser projector was the last one. Christian's right. Okay, concentration, return color. Oh, I need also extends render task. Need to put this everywhere. This one anyway is removed anyways. Render tasks, return color, viewport. Okay, that's three different render tasks. Parent, return color, and then shaded. And this will be not shaded mix. Else if this waiting for reflection, then do this, and this is basically oh no, this is return collision and this is return color, but this will be merged with execute. Return color. Alright, and this will be basically C or color. Oh, we can do that. Waiting for reflection. I really want to merge it now, actually. But then we don't have to execute here. I mean I can't merge it. Alright, let's do it. Return color. This waiting for reflection false. parent, basically this. This, well, it's missing. Oh, so many. Also this parent. So many errors already in the code here. Need to go through that whole thing. There's some stuff happening here else. Okay, no sloppiness here. Waiting for collision. All right. Let's do it. R task. Color. Oop. Oops. Parent this. And we have position, direction, depth. And then we close that and we do this, waiting for reflection. True. Waiting for reflection. Okay. This actually might work. So strange. It is so strange because you start like with one task and will be removed from the queue, executed, adds another task, but it's appended as a parent to the other task. Then the task returns, calculates, returns to this parent again, adds another parent, returns again, adds maybe another parent, returns again, and then returns to the other thing. So it's recursive, but it's like a tree a graph or a tree that you're running here. Okay, that's render task color. Render task viewport is also done, I think, yes. The sequence is complicated because I need to flatten everything to make the ray marching task. So this is like the ray tracer. Okay, I don't know if you missed maybe the beginning. We're running ray marcher currently, and we want to outsource everything to the, not everything, but actually the tracing of the path can be done on the MCU, because they're not, we can do this with fixed point without division and square root and so on. And yeah, I know. There are some other people that joined also want an update maybe. So this part where we calculate the distances from the objects and the stepping, so that could be like 64 individual steps, and then calculation and so on. Also, it helps me. This will be outsourced to the MCU when the MCU is ready. So what we did is currently we made a task to start calculating the ray, then made a task to calculate basically the color of this ray when it returns. Then the task is scheduled that calculates that the collision here, the stepping. This is done on hardware. Then when this is done, the task is scheduled to calculate the shadow ray. When this is done, the task is scheduled to calculate the color in reflection direction, and then this has even more tasks and so on. And when everything is ready, the colors are basically collapsing, and at the end we just put the color in the viewport and that's it. That's why it looks so complicated. In the end, it actually, I will never understand the code again once I'm done. And it could be optimized as well, simplified a little bit. Okay, render task, execute. I don't think we even need this. This is just prototype. Only one of objects, or so it's not ray tracing where we would just trace like calculate a ray per additional object that we can reflect to or whatever. There is like we calculate the exact bouncing direction, like the reflection direction, like here, or this sphere has it's based on the normal, and then we calculate basically the distance function to all the objects and step through with the biggest possible distance steps from the other objects to find like either if there is a shadow or the reflection direction, what color or what object we hit, and calculate from there on also the color. So we can even go deeper in the more iterations here. I can maybe show it like if we have like one reflection step or multiple, we could make the objects more reflective, and then you will see that this. Oh wait, I think there is a scaling on the thing here. Let me check. Oh no, I think I just zoomed in. No. Hey, why is it scaled? Display block. Oh wait. I change it here, not there. Damn. Yeah. I don't do this. I don't need that display block. That just I was wondering why it's not way 80 by 720. Now it's square. Yeah, it won't it doesn't render because it doesn't compile yet, but I will make it compile quickly. Okay, so something was missing. Yeah, render tasks. Okay, let's rename that. See where it's complaining. What is happening? Uh-oh. Oh, yeah. It was calculating for that long. Ooh, okay. This takes a long time on the CPU. So maybe we make it. Yeah, now we have a little bit more, but you can also see the disadvantage if we cancel too quickly, like too few steps. No, it's not rendering with the cluster yet. We're trying to make it render with the cluster. Okay, let me change the resolution so it doesn't take so long. And yeah, alright. So let's do it 640 by 360 for now. As yeah, here we go. And zoom in a little bit. It's enough detail. Now we might want to render it with the tasks. What we can do is we can, I have everything implemented on this side, not hardware yet. We need to interface where right, not this part. Scheduler. Basically collision. This one needs to go on hardware. Also some translation of fixed point arithmetics in between. But for now we are running it from that it's not done yet. Yeah, scheduler execute. Okay. Static execute, and then we will just perform the tasks, I think. Maybe do some iterations or whatever. While that feels wrong. Task length. Do that, and then we can do that. We can perform just like a number of tasks. Let's say we perform 1000 tasks, 1024 tasks, and then we will just do, sorry. Confused. Not in C++ here. And then perform a put image data maybe. Oh wait, we would need like to, it will be updated. Yeah, well, true. It will be updated. Oh no. Scheduler execute. Okay. Request animation frame. Okay, let's do this. Request animation frame. Is it window or is it document? No, it's window, is it? Callback. Scheduler, we will just run it like 60 frames per second. Scheduler if okay, that feels better. So if there are still tasks, we can do it again. Oh, we can just run scheduler here. Okay, let's do run scheduler. Let's call it like that. So it's actually if task length request animation frame run. So this will basically update, and then oh, did I delete everything? No. Execute. Okay, this part. Request animation frame, because we don't want to block the browser, and a request animation frame is just like set timeout, but it runs like every frame or whatever, so we can update like the progress of the rendering while it's being rendered and while it's maybe stuck or whatever, so we see something at least. And request animation frame is just called 60 frames per second. So there's no, or the highest update rate that should be available there. There is no point in calling more often. Or should we? Wait. No, we can. You know what? Maybe it's better. Set document or window. No, set timeout, and then run scheduler and 0. 1 million FPS. Time handler, timeout number. Okay, 0. I think timeout passes to the browser. Okay, let's do it like that, or 1 millisecond. I'm worried that it will be too fast, too many things. Okay, image data. I can also move that part here and then just run one task there. Execute, and this one will what is it, shift? Array shift, array. Yeah. Tasks. This task shift this also the return value? Okay, shift, and then we do execute. I have no clue if that works. This will be a huge clusterfuck. So we keep the old ray tracer. One fast CPU. It totally depends on what you want to do. I mean, like multiple cores is nice if you have like different tasks that you want to do at the same time, but usually the bigger cores are like more capable. Like, I don't know, floating point units and stuff like that. It really depends. 4 cores, 64 megahertz. I would go like something maybe in between. It's hard to maintain. I mean, they are blocking each other, accessing like the memory bus and stuff. I have no clue. Actually, I don't have a preference. On like PC, I would rather take a limit, speed limit somewhere, because they get like really inefficient at some point. So it's better maybe keeping the CPU cool, having more tasks, because yeah, I know 2 gigahertz is good enough for in most cases. And usually, like, I mean, PC isn't comparable because the software is made for, like, especially the one that requires the performance is usually multitasking capable or using GPU or something. I'm not sure. It really depends what you want to do with it. Yeah, mine too. It's totally fine. Yeah, MCUs. I don't know if you need it. I would take like the smallest possible that is able to complete the task. And with a little bit headroom, I mean, for improvement later, but usually I don't know what the benefit would be having 4 cores if you never use them, if you only use like one. Then I would rather go the 168 megahertz, because then you have like the possibility to maybe do fancy stuff like HDMI. In that case, that would be more or less perfect for HDMI 640 by 480 if you can do DMA. Stuff like that. There are like things where you need the speed, otherwise I don't care. 64 megahertz should be enough for everyone. $252 really? Yeah, HDMI. Yeah, but at the no wait, HDMI. I think like 640 by 480 is 160, wasn't it? The RP 2040 also is doing that, and it's clocked up to 160 or something. Oh really? 252? Oh okay, then I'm wrong. Oh, you're right. It's from 133 to 252. Yeah. Okay. I was wrong. And it doesn't matter. I mean, you can still maybe try to overclock the 168 megahertz MCU. Should be doable. %, yeah. That works in winter. Okay, illegal constructor. What is this? Oh yeah, super. Oh, what a brain fart. Where is it? Where was it? Render task. Okay, here we go. Some people got it to 1 gigahertz. Hey Sonic, when did you join? Lurking today? What is that? Pro render? What is this? What is this? Path-based traced rendering engine that enables screen. Okay, yeah. That's basically it. Came late then lurked, alright. What is the issue here? What do we have? Okay, origin. We have something. Direction is undefined. Get reflection. Where is this coming from? Let's check. Execute. Oh yeah. This is basically wrong. I need to remove that. View. Where is it? Where is it? Color. This is just the old code. Position, direction, but it was missing anyways, so it will crash anyways. Huh? What's going on? Tasks? This task's length, okay. Oh wait, it's done. It's calculated. Or is it stuck? Let me check the scheduler. Okay, how many? Oh shit! 230,000 tasks, nothing completed. Oh. Neighbor talks. Hello. It might calculate, but really slow. Moin moin. It calculates really slow. Let me check if it's doing, because that feels like okay. Okay, how many tasks it is still? I think there's nothing done. How many pixels do we have? Uh, 320. No, wait. 640. 40 times, was it 360? Damn. It's not executing anything. Okay, so let's take a look where it is. Okay, it adds a new task. That's a viewport task. Oh wait, it's still processing the... I should do an update how many tasks are completed. We just need to wait. Need the progress bar, yeah. But we actually don't know how many things are done there. Everything is working in parallel. At some point it might show up. Maybe I should take a smaller resolution. Okay, let me stop again and then see where we are. Okay, I think it's still scheduling tasks. Oh, it is at render task color. Wait, let me check there. Render task collision. Okay, peeps, it's calculating something, but I want the segments to be... Okay, if you look here, it is at render task color, and when we look to the end of the queue, it's render task collision. So at some point, if we continue, if we continue, it will start to grow because there are more tasks. Okay, let's check. Render task. Oh, it's still in the viewport. What? Or maybe it's render task color. Where is the collision? Okay, still color. Huh? I have no clue why I don't see anything. Okay, let's check. Still. Viewport. Why is there still viewport? Didn't we see like collision tasks? Huh. No. It's not the limits of okay, let me, you know what? We take a smaller viewport. Smaller viewport. Here we go. Ah! Aha. This makes sense. Okay. We are further. Here. And this parent collision, return collision, this parent, and this. I really want a new line here. Do I have more parent collisions here somewhere returning? This. This. More errors. P. There is no P anymore. Call P normalize. Okay. Light position. Okay, super parent. Okay, let's see. This direction, okay. Which task is this? Collision still. We are at collision. What? Here, render task collision. Huh? Oha. Where's this coming from? Okay, let's run again. Undefined. Who schedules collision tasks that are undefined? Light direction. Light position. Mon, hey. Yeah, I need to find the issue who is wait, color render task collision and scheduler render task collision. Okay, let's find out. Okay, this is already undefined. Distance. Wait. The direction. Huh? Okay. So the issue starts earlier than that. Viewport. Okay, let's go viewport. Parent position, tier depth. Position. Tier depth. Okay, viewport. What is this? XY position direction is missing. Position is right here. Here we go. What's again? Yeah, origin. There is no origin. Where is my viewport? We are almost there. We are almost there. Looks like we will be programming it, or I will be programming off stream the thing, but I will try to. Hey, Naper Talks. Is it on GitHub? Share it? Yes, I can do it. I can share it. 1 second. Let me find the issue. Okay. So position at the steer scale origin. Is there any origin anymore? No. Ay. At least I want, before I check in, I want to remove the runtime errors. Where's this coming from? Huh? Oh, it's calculating the array position. So it's writing to the array. Okay. Viewport. Yeah, basically this. X, Y, this. This is stride. I should also. All right, I will leave it there. But oh, it calculated something. Oh yeah, it's empty now. It's empty now. Oh, the schedule is empty. No. Scheduler, render task, scheduler. Oh, wait. Can also return. Yeah, I will break to put the image, scheduler execute, and then there's no empty. Okay. Alright, let's do 160 by 100. Wie Sie sehen, sehen Sie nichts. It's a common occurrence when coding graphics. Black mirror. Here we go. And it's really slow. A black hole, yeah. Let's do 320 by 200. Oh, Here we go. Bloop. Maybe I should append it like different way. With priorities. Foo! 4,000 Colombian pesos! Yeah. $1. Thank you. Did you see? You've been listed in the supporter list because of all the donations. In the latest video. All right. Yeah, nice. Oh, by the way, I didn't want to show it. Let's take a break for a second. This device arrived. It works. But here, my old mini discs. It works. I got, here's my stack of mini discs. I was searching for I don't know 4 hours to find my old device, all my mini disc collections, and I bought even new mini discs. And it's using WebMD, where you can actually hack it. Should I show it? I didn't want to take this break, but we will take it now. I will show how it looks like. So there is a USB port. I will connect that. Here we go. Maybe we should put something on there. Okay, I needed to use Zadig to basically attach a Win USB driver to it. And now it's showing, what is this? My recordings? Well, what is this? Okay, anyways, I can play or whatever. Can we make it loud? Do I have a microphone input here? Speaker, wait. Oh, actually I can. This is the music that I listened to when I was... Yeah. Copyright. Stop it! Yeah, so we can... it doesn't run like... It runs from the device, so I can only control the device. Now... I can... Look at this. You can do... this USB. The issue is I can upload maybe a track. Let me. Hey, Johnny! Now I'm doxing myself. Wait a second. I will try to upload something from... do I have a wave or something? What does it support? Yeah. Oh wait. Oh no. I don't know what happened. It locked up. The browser locked up when I moved it. Or is it... No, it's the Windows. Is it Windows? Windows Explorer. I can't do anything. What's going on? I can't. Come on. Oh no, I don't want to. Okay. It locked up, but I will upload basically some free music. In my YouTube YouTube music stuff. Okay, here we go. Maybe you will. Where is it? Okay, I will upload sunspots. Here we go. Mode, file name, yeah. Okay. Now it's uploading. Never tried it. Wait, what? Is it so slow? Is it converting first? Probably it's converting. Oh wow. Yeah, it's still converting, yeah. Should have taken a shorter one. The web page, what? Oh, it's using web USB. Electron? Okay. Why is it so slow? Give me a progress bar on the conversion if it's so slow. Damn it. I mean, I can take a shorter track. Okay. Oh no. Stopping after current track. What kind of cancel button is that? It's almost as good as my cancel button. Oh wow, look at that. A CPU is actually busy. It shouldn't be that slow. I mean, it's an MP3 track, please. Okay, it's a little bit longer one, but oh damn it. I mean, I can just reload the page. Here we go. Reload. Let's take a shorter one. Okay, here, this one. Et voila. 1 minute track. Maybe I should use the sting instead. Okay, so while this is running, I got just another device. 3.5-inch USB, but 286 SX. I think there wasn't like the 386. It doesn't fit on a footprint of the M.2. So a disk drive that's standing up like that. I might still do it. I remove the cable, attach it to USB on the M.2, and then I can just insert a disk. Oh, excuse me, Mr. Never mind, connect it to your phone instead. Yeah, that's actually... I wanted to show you the homebrew stuff. It's like, I mean, the whole project, the web interface is only like running the stuff, the Linux version, I think, of everything. So the homebrew stuff, the hack, it's not visible in the browser version. We have only like an assembly, and I would really love to see like how it works. Downloading the you have like the option to download everything, but I want like individual blocks or something. So and writing individual blocks. I'm not sure if this is currently possible with. It should be. I mean, if you can read the whole thing, you should be able to read it block by block. But it's really slow. It took me also to like back up a 1MD. Maybe one of the rare things only possible on Linux. Yeah. I mean, the code should be like C++. Should be. Why is it converting that long? Wow, still utilizing all my cores. Look at that. Something in the console. I don't know. Let me check. Whoop. Oh no! This is the course. Of course. Damn it. Okay. Yeah, that's an issue. We can't do it. Shit. Can I disable course checking here? Site settings. Can I do privacy? Is there like permissions? I think it's not as detailed. Okay, yeah, let's forget this. Okay. So that's that. Oh, I'm hungry now. Let's fix up. Yeah, that was this thing. I got USB disk drive from China. It took a little bit longer. I ordered it at the first, I think even. And some mini discs. Did I get anything else? I don't think so. Is this my pants on there? It's out of view. Okay, let's fix. That was the short break. And let's fix our code here. We should the raymarcher. Oh yeah, we wanted to maybe prioritize something else, like okay, so what I want to do is have smaller segments computed before we continue. How do we do that? Or I can schedule the type of to the front of the queue, maybe some type of tasks. Okay, render tasks. Okay, schedule as task. Priority. It's not the highest priority. It's the lowest priority. Push. This is crazy. What do we? What's the push to NQ now? Push. We have that's the stack. Shift. Shift is removing. Unshift. Yeah, might be. Yes, it is unshift. You're right. Yeah. Shift. Unshift. It is a higher prioritized task will be just put to the front. Okay, render collision. Render collision parent. Okay, collision doesn't do. This is basically one. Anything that happens after viewport is higher prioritized. So we don't go depth first. We go depth first. Here we go. you can see it rendering. Okay. So it's a little bit cheating. We could do also web workers that calculate that to improve it. Here comes the darkness. Yeah. Now we will disable stuff and look for the issues where it's happening. Okay, so basically render task color. We will do render collision, and then what we do is basically, if collision, then we parent return. We just do this all the time, and we will just return the color of the object. Okay, and this will be, I think, call collision object material color. Okay. This is simplified rendering. It should just show the objects, maybe, if they're... Interesting. So we don't get even that. So now we can actually check where it's happening, the issues here. And it's something really stupid. Here. It's never returning collision. What? Huh? Wait. Oh, it's null, null, null. But when does it return anything? Wait. Oh, copy paste. Okay. Peeps. I'm stupid. I never return. It's copy paste error. Okay, we will be soon there. Soon. Collision. Okay. Yeah, copy paste. Ah! Here we go. Ah! Okay. Okay, we got so far. Now let's remove our hack and see if we get some shading, some shady hippie, yeah. Okay. Oh no! What is this? Ah, there is no P. Call. Ouch. Distance to light is also this. Now with the shading, it's getting shady. What? Yeah. Okay. Strange. Oh, wait. What is it again? This. Oh, damn. Waiting for shadow. This. Quite a lot of dereferencing. Yeah, a lot of different dereferencing here. Ouch! This again. Here. Boom. Okay. Ah, the shadow calculation is broken. Yeah, we need to revert it. Ah, damn it. Yeah, the issue is I changed the direction of the shadow rays. So I determine if it steps to from the light source to make it simpler, or no. Let me add just a bigger threshold. Wait, render task collision. Render task color. I can do more shadow steps. Let's try 64, if that helps. But I need a bigger threshold to accept the tar. Yeah, it got better, but I think I need return color, return shadow, return collision, waiting for shadow. Oh wow. It's already big. This is like way too big threshold. Okay. We need to fix that. Damn it. Okay, I will implement an extra shadow collision calculator. Render task collision. It's almost a copy. Almost a copy. Task shadow. Yeah, reflections are good. I will add max distance, max steps, and now we will reverse it again. So waiting for shadow. Shadow will be here. Distance to light. Light deer is basically light pause. I need to change that again. And not light pause, it will be call P M.2. And then I need to take a peek to is in shadow, and we need to get basically this. This is what add the, yeah, that's shadow point. SDF, it's 50. Okay, 50 iterations. Oh, okay, let me get that. Tried to change too much at the same time. Task shadow execute. Okay, let's check if we can fix that. Okay, that's max tabs. See. Oh, interesting. It uses a different trick. Hey DFGA, we are trying to fix our ray tracer here, or raymarcher, to make it run on the MCUs. So their distance to light is basically, yeah, I need to be sure that I don't mess this up. Return collision. If collision you know what, I take that return true. This is in shadow. Okay, so basically in this case the what? Get hot VCC? No, it's just getting hot. Like it takes 170 milliamps, the MCU, and or are you're talking about a serial chip, aren't you? Yeah. And the small LDO is just overwhelmed. And basically there are other chips, but they draw even more current. So on a new design, I'm switching to a volt to step down converter to basically at least take the load from an LDO. Collision. Yeah. Yeah, that was if you watch the video, you have a summary of that on my main channel. Getting hot wasn't actually the issue. There was swapped TX and RX in a nutshell. So this breaks on the max distance. Break. This can also break. So break. This breaks. And this will basically ensure that we know if call D is shorter than that we hit something, an obstacle, otherwise we didn't hit anything, and max distance is close to yes. Oh yeah, that issue, it getting hot. It's basically some stray currents. I don't know, maybe through the GPIO or something. And we had like a voltage drop of 0.6 volts, which was basically reverting the voltage. So from those low side switches. So I completely skipping that, and they're all powered now, and I can't use this function as of this one here. I can show you the M. Focus! Ah! Yeah, I'm using the same trick, just you can flash them at once with the link key. It's actually, it seems to be more reliable on the small matrix. I don't know if maybe because the traces are shorter. The only issue is that I can't use the bus, and yeah, when I disable the programming interface, I need to disable it to use the bus. Let's say it like that. And now they are addressed from the address bus individually and so on. So this is how that thing works now. Okay, let's finish that. It's already 3.5 hours. Coding takes so much time. 0.1. Okay, shadow. This, yeah, they have a unique ID, but I'm using the option bytes that you can program those with an index. Basically, I'm using an index, and I on this programming board here. Where is it? On this programming board, I have since it's only one card, I have one pin that connects to the pin of the LED. So I can basically set it high or pull it high, and the small MCU will notice that and see, oh yeah, someone wants to set an ID. And then it programs itself the ID in the option bytes, which are basically permanent. And once I'm switching the card, I can put it in this thing, and then I could even like give them increase like by 16. So like each of the MCUs has like a consecutive or like a sequential ID. And I have like an exact position in the 3D array. So we can use the LEDs to basically show something off. It would be like the two examples that I want to show in the video. The ray tracer maybe, hash calculation ray tracer, and maybe some blinky lights. So, and the ray tracer should be called no, I'm not using Copilot. I'm gonna wear the flash. No, it doesn't reprogram it. It reprograms it once. Now it only like I disabled this. I just reprogrammed them once, and now they're just I'm using the address bus just to activate them, and then where they recognize their own flash, it will just blink. Yeah, it's some few bytes. No, but the flash is reprogrammed when I flash it. No, I'm not writing it all the time. Okay. Uah. Yeah, I'm not sure about the shadow rays though. Oh, it crashed. There is it again. Huh? What did I do? Wait. Light tier. So what are you doing at the moment to get the ray trace on the LED matrix? Okay, I will update you in a second. Light pause. This light pause. Shoot. No, it's just light pause here. I switched positions. Okay, so idea is that's still what? Yeah, it's this again. So this is a ray marcher, and oh no, the issue is still the same. No, what did I do? I need to compare it. Something's off in the code. Okay, quick recap. Oof. Okay, where is it? My MS Paint. Here we go. So ray marcher sends ray, and since it's like it's marching, so it's an iterative process calculating the shortest distance to each of the objects, and basically I want to put the marching on the MCUs because that can be calculated easily. I don't need any divisions or square roots or anything there. And then like the host PC will calculate the reflection direction, normals and everything, and will set off basically the next task to march. We're currently struggling to calculate the shadow ray correctly. I need to fix that. Otherwise, yeah, this is that. It's different. Okay, let's see. Oh yeah. Here we go. What? Oh, it destroyed itself. Okay, yeah, right. Scope. Yeah. Okay, now. Last try. No! Still broken. Where is it? Where is it dying? Yeah. I need to compare it. Yeah, it will be parallelized on the not 4x4 matrix. It will be on this one. We have 10 cards, so it will be 160 MCUs. And each of them will take basically a task to trace array. Creepypasta. Yeah, it's copy paste, creepy paste, yeah. And the task shadow. I did it right. I did not hit her. I did not. Oh, hi, Mark. With the dark contrast. Yeah. Render task shadow. Shadow steps. Shadow steps are 50. I don't know. Okay, let's compare again. Okay, this is up there. Direction P, direction, shadows, direction, light position, distance. Okay, normalize. Sub P, we have that in the main thing. Okay, and this is now stepping. SDF. Yeah, Turbo. Okay, this is basically that if return true. Wait a second. T plus. This is the issue. We're going the wrong direction. Call. Oh wow, this is completely wrong. Also in the other step, I think. It's not running on the MCU yet. We need to fix that and then convert it to integer and then put it on in code. So this won't happen today. I will just fix the ray tracer and upload it to GitHub so you can play around if you want. So we'll be finished in like 10 minutes, no worries. Oh wait, not called it this dear. What? You're not leaving yet. You just missed the best part. Also, this is wrong. You want to see that? Oh. It's broken. Yeah, I'm almost done. Wait, where is this? Oh yeah, wait. There is still this crappy pasta. This thing here. Okay, let's remove this. This will render. Here we go. People, let's record this moment of truth. What? No! Okay, maybe I shouldn't change that for now. Wait. T plus equals. Okay, sorry. Okay, here. Now. Huh? It paused and it... Blind man raging. What's going on? Damn it. Why though? Huh? No. Oh yeah, there is a return missing. This is render task collision. Wait, I can just break here. But why would it happen here? Oh, P. What? Okay, this is now correct. The shadows won't be correct though. Huh? Huh? Okay, I have no clue what's going on here anymore. Why is it all of a sudden broken? It doesn't render at all. Nah. Okay. You're dismissed. I still try to fix it, but no, it's not a scalar. It's a collision object. The more I fix it, the more it breaks. No, wait a second. That's too. That's even more wrong. Copy paste. Yes. And logic of what? Exactly. I need to copy paste again and fix this. This is like a complete different thing. So for each point in space, we are calculating the shortest distance to all the objects and return a collision point in space with the nearest object, the distance to this object, and yeah, that's basically it. And what the shadow, this is shadow, yeah, the shadow task, yeah, I just copy pasted part of it, that's why it's not working anymore. So basically I shouldn't do this. This is stepping P. I should do shadow point. Basically, let shadow point be this. This is the starting position, and what this does is, this is the old scaling. We need to find a yes. So it has a max distance, which is basically the distance that we calculated from the light, and now we are stepping through the space to see if there is an object that's below the threshold. That means it would cast a shadow on like in this path of light. But I copy pasted trash, and now I should feel bad. So I don't even need. Oh wow, that's like a different. Oh damn, I need to fix that as well. Yeah, shadow P is pause. This. Oh. Yeah, let's take that. This here. This is now one-to-one copy of that, I believe. So shorter, this is shadow. Return collision. It's variable. It uses the shortest distance that it calculated for the next step, so it wouldn't ever overstep. It just like gets closer and closer to the next object. That's why it's checking versus the threshold. At some point, the distance, it will never be zero if you're not like going directly towards a wall or box or whatever. Yeah. Let me check distance. What? Summing up, yeah, usually. I just want to remove all the differences that I got in the code. And currently I don't see the issue. Okay, this is crap. It just breaks. It also breaks if the max distance but why does it cast shadow? Let me check that. It only does it in this case, so there must be an issue maybe with the starting position. Collision normal, waiting for collision, collision normal. Collision point. Distance to light. Light direction. Okay. Let's check again. Oh, wait. Let me check that. Oh, you're right. Are we checking versus T? This is because I'm using the same code. T is never added up. Okay, that's all right. I shouldn't here waiting for shadow. It's never checked versus T. It's checking for distance, travel distance. Like this is what it's testing against. Let me compare that calculation. So light position, subtract P, normalize. Distance to light, sub P, length, shadow P, add, direction, oh, it uses a different light direct, it uses this one here instead of the other one. Okay, that might be a difference, but I would Okay, let's see. If this does the job. Will there be a vote? Yes, I hope so. Still broken. Oh. Okay, let me add shadow task returns. Bye bye, Dev. It returns basically to the parent task. So the parent task is hibernating. Here, and once it's done, it will just call return collision. Shadow on the ground. Let me check. This is basically, there is like some vector is wrong. So if I let me just I can just set it to shadow false, and there will be no bending. But we don't have any shadows anymore. So we have reflections and so on. I think it's only like one level of reflections. So it's certainly this shadow task that is broken. It's waiting for shadow, and once it's coming back here, collision call, then it's entering this here. Then it's just calculating the color and then checking if the collision that we... Oh, this is wrong. Shit. No! But it can also be, yeah. But why is it null? That's strange. Should never happen. Huh? Oh. Really? Okay. But why do we get null for collision? Huh? Why does it... Or Okay. It needs like to, it doesn't need to, alright, now everything is in shadow. Interesting, look at that. We optimized it away, everything is broken now. Alright. When is call? Also, this whole thing runs when waiting for shadow is true. Shouldn't it be set to false once the shadow check has run? Yeah, it should be. You're right. You are correct. Wow. Maybe it's now faster. Good night, Basil. It's still. Yeah, doesn't do a thing because it never comes back into this into this function. So actually, thanks for noticing, but doesn't help. Port Doom on the cluster. Yeah, that's your job. SO5W. Hey, I want to get started with electronics, and it's always wanted to know what was your career like? Did you study? And yes, when yes was Deutsch ist auch fine. Yeah, so maybe for all the other ones as well in English, I was studying computer engineering, not computer engineering, basically software engineering. Studied that for a long time, and I was coder most of my career, and that was always a hobby, and I'm not good at it. my electronics sucks, but I like it. That's the story. Doing it for. I mean, I didn't do PCBs in the first. Oh yeah, I etched PCBs first year when I was like in this rabbit hole, and then making stuff like that came bit by bit. All right, now why do we get false here? Shadow. Ja, bitteschön. Yeah, but they got more expensive. They have like hidden costs everywhere if you want like special things. Okay. Max steps call. Wait, we can also break here. But why though? Oh wait. It shouldn't be an or, it should be an and. Wait. So if this isn't true, it won't continue. Oh no, it will continue. Ah, shit. Okay. If it's not... Yes, you're right. No, you're right. Please. No, I don't see shadows. Yes! It works. Let's render. Oh, you know what? Let's do blocky. Let's do blocky blocks. Maybe. I know. We could do like squares, small squares, but I rather want a higher resolution and higher depth. Okay, so let's go 640 by 360. And let's go reflections. More reflections, shall we? Max depth. Let's go 4. And more reflections, so we need to change those things. Yeah, engage. Yeah. More reflections to the surfaces. And 50% here, and let's render it. Okay. This is slow. If we can run this on the MCUs, this will be amazing. There is no transparency, refractions and so on. Because it's using those tests and everything. DKB Trace, Deutsche Kreditbank. Yeah, it's highly unoptimized. we could use worker threads. Povray, yeah. Oh really? I know Povray. I calculated actually animations for my game that I wrote in the 90s. So I used Moray for editing and Povray for basically rendering them. That was cumbersome. Almost as complicated. It's complicated as Blender. Here we go, people. Oh, I'm recording, but it's taking so long. I'm wondering how this will take even longer if we try to outsource it to the MCUs. We could actually increase. Oh, wait a second. We could improve it by not set time out. Let me check. Set time out. If we pass a 0, next event cycle. Okay. %. No, it's only using one CPU, not even 100%. Oh, what the F? Yeah, it's probably garbage collecting all the time. Oh wow. Look at that beauty. We see reflections in reflections. Yes, yes, it returns. Yeah, a collision object, and the collision objects are created, and the vectors as well. The vectors are not performant. Yeah, but wait a sec. No, the tasks are not the performant thing, because we ran it with collision object before and it was fast. Here we go, people. Are you loving it? I love it. I copied that image and paste it in on my Discord, okay? Here. I put it in lab. Boop. Almost rendered on an MCU cluster. Okay, we love it. I will upload this to GitHub and anti-aliasing. Yeah, I wanted. You know what? Here, publish on GitHub. Publish public. Here we go. It's. I will tell you. Let me tell you something. Not sponsors. bitluni. Repositories. Supercluster 2, and here is your raymarching. Okay. Have fun. It should be public. It is public. Is it? Yeah, it is public. Is it public? If it's not public, tell me. But I think it was public. Yes. Super slow. I will continue on that. It looks cool. Yes. All right. So what I thought, usually, if we render basically diffuse, we calculate like the light. We calculate the light and the normal. We calculate the diffuse value. Oh, I'm tired. I can notice that. I noticed. Oh, damn it! English broken now. All right. So when we calculate the diffuse value, which is basically the color, how well lit the color is regarding to the light of source of light. Damn it, what's going on? We use like a dot product of normal and direction to the light or whatever, like that, and multiply it yeah, I'm streaming at the same time, so might be that issue. And what you can do instead is like only calculating light like bouncing off one ray in a random direction, and if it's the like photon tracing basically. And what I thought is like global illumination or photo tracing, because that would simplify the way like that we calculate stuff on there, like the lighting. We could have global illumination, and specular is intrinsic, because if you hit like a volumetric light source, the source has to be like rendered like a sphere that's with emission. That would cause like to reflect basically a specular. Why is my system so busy? Is it recalculating again? I hope not. My system broken. Oh, my CPU. 50%. What's going on? Why is my PC so busy? Okay, let me... Okay, that's my PC. Anyways. Yeah, so basically we could render always trace one path and then scatter it in a random direction with the probability of like the reflective, like you have the roughness of the surface determines like the probability in which direction it will scatter. That's like okay, you got it. Wait. So we just use random number generator to determine the most probable direction, but it will be random at the point, and we can trace the same ray multiple times and then add all the colors up, average them, and then we get a smooth global illuminated thing. So like we get some color bleeding on this white square here from the blue box and so on. So that would be nice to have, but this is something for the future. Let's just finish that one. And we have a parallel ray tracer here, raymarcher. That's cool. Nice. People. We can throw away the other stuff here. Okay, get normal and so get light. Here is shadow, get reflection, renderer. These three functions are basically flattened. Anyways, thank you for watching. I'm tired. I can't speak anymore. I worked for a lot of hours today. Yeah, over 12 hours. 12? No, since 10? 14 hours. Alright, bye bye everyone. Good night.